Question number 8 from exercise 6.2. Using theorem 6.2, prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. Okay, so triangle, right? Let's draw the triangle. Yes, now see, prove that line joining the midpoint of any two sides of a triangle. So any two side, name this as M and N. M and N are any two sides. Prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. Is parallel to the third side. MN is parallel to BC. So given. What it is given? MN is parallel to. Wait. Prove that line joining the midpoint of any two sides of a triangle is parallel to the third side. That is to prove. What do you need to prove? MN is parallel to BC. Prove that the line joining the midpoint. So M is the midpoint of AB of any two side. Okay, N is the midpoint of AC. So I can say M and N are midpoints of AB and AC. AB and AC, right? So now in proof, it's very simple. We know AM equals to MB. Reason given. Yes, M is a midpoint. So can I say AM upon MB equals to 1? First equation. Then next one, AN equals to NC. It is given. Yes. Or instead of given, we will write it is midpoint. That will be better. M is a midpoint of AB. And here also, N is a midpoint of AC. Name this as 2. Next one with AN upon NC equals to 1. Name this as 2. So from 1 and 2, see, you can get this AM upon MB equals to AN upon NC. AN upon NC. Very simple, very important. This is the midpoint. AM equals to MB. Midpoint means what? Same length, no? That's why the ratio will be 1, right? Same here also, N is the midpoint of what? AC. So AN equals to NC will get, right? And it is also 1. So see, RHS both are 1. So now from 1 and 2, you can say AM upon MB equals to AN upon NC, because things which are equal to the same thing are equal to one another. Name this as 3. Name this as what? 3. Now, after that, what we need to do? We need to do nothing. Just we need to say MN is parallel to BC. Why? MN is parallel to BC by converse of BPT, right? Hence it is proved, because AM upon MB and AN upon NC it is. So we have the statement of converse of BPT. If a line divides any two sides in some ratio, okay, so it is parallel to the third side. So that's why MN is parallel to BC.